Right. So, my friends, what is the difference between evaporation and condensation? Who's going to start us off? I heard some great conversation. I heard some really good science happening. Who's got something to share? Go, Miss Haley.
Okay, so for condensation, it's when water vapor rises and kind of cools and condensation, so it becomes droplets.
Okay, I got most of what you said there. So, condensation starts out as what kind of water? Water vapor, right? So, water vapor. And just to be clear, that means that it's water in the gas state, right? You've got solid, liquid, gas, and plasma, and this is water that's in the gas state. So there's still oxygen and hydrogen, okay? But it's in the gas state. And so what is it doing?
It rises.
Okay, so why does it rise? I was just looking in your general direction, but I can ask anybody. Why is it rising? In the condensation.
Is it because it's less dense?
Oh, because it's less dense because it's temperature-wise warmer. Yeah. So nice job. High five for you. Good work. Yep. Rise because it's warmer. But to be clear, that rising because it's warmer is not the actual act of condensation, but that is what water vapor generally does if it's hot, right? If it's warmer than the surrounding area, because warmer things rise because they're less dense. All right, so that rising is not the condensation process itself. What is condensation? What does that mean? What does it mean to condense? You kind of were there, but then I cut you off. I'm sorry, Haley. Do you want to tell me what you said?
After what?
After the water vapor rises?
Yeah.
Okay, so it's going to cool. What? That's what I want to know. What does condense mean? Goes together. So what's that? So it cools and forms water droplets. And so the water droplets, that means that it's in what form then? It's now liquid, right? So it's going to form liquid. Who said that? Was that you, Colin? Oh my gosh. Does droplets have two P's? Or just one? Okay. I'm not a good speller. I still learn. All right. So the liquid or the water vapor cools, forms liquid droplets. Now, we talked about this yesterday, and this is the piece that is really important for condensation. Do you remember we had the beaker, we had the hot water, and was the water vapor rising as when you were first watching it? Remember you did that first observation, y'all were making fun of it. You're like, what is it? I see a cup of water, right? What is it? You didn't see much, did you? And as a scientist, not seeing something is just as important as seeing something, okay? Because not seeing something means that something is happening or not happening. Are you with me there? Okay? When we added that match, what did we add to the system? We added fire. The water was already pretty warm, so the water wasn't getting warmer because of the match. What else did that lighting the match and holding it in there do? It added smoke. And what is smoke? Of whatever, of stuff, right? In this case, wood, right? Little tiny bits. And why were those little tiny bits necessary? Or let me back it up. What did those little tiny bits allow the situation, the system to do? What did you see as a result?
I think the water condense on them, so you could see it.
Yeah, and then you could see that you could see that convection current, right? The key was that there were little bits of dust, little bits of smoke that had to be there for the condensation to occur on. Okay. Was there any other condensation that you saw or that you experienced when you were doing this? Or was it just the cloud that formed inside the beaker? Flip your blue sheet over if you have it out. Flip your blue sheet over, and I want you to look at step number 3. What did step number 3 say? Wipe inside your beaker. What? Say it loud. And why did you have to do that? Because there was condensation. Question?
Like where the ice bags were supposed to be, I don't think that the glass wasn't fogged up.
The glass was not fogged up right there. That's absolutely true. But where was the glass fogged up? I heard a lot of mumbling and nothing really that I could pull out. Say something. On the sides near the water, near the warm water. So there was water vapor that was coming off of that hot water, and then it cooled when it hit what? The glass. And it cooled when it hit the glass, and then it formed liquid water droplets. Okay? So this condensation thing can happen whenever you've got water vapor that comes into contact with something cooler. That's all it is. Okay? On a hot summer day, we can't really imagine it right now super well. Hot summer day, you are, out mowing the lawn, you go in and you get a Pepsi. I don't know, I'm just going to make that, you get it out of the fridge. Does it have condensation on it like when it's in the fridge? No, but when you bring it out and you sit out on the deck and you're looking at that Pepsi, what happens to it? It sweats. Where does that water come from? Does it come from the Pepsi can? Where does that water come from? Water vapor where? In the air. In the summer, it's super muggy out. You know what I'm saying? Not so much now, but in the summer, it's super muggy out. That means there's a lot of water vapor that's just out in the air. It comes into contact with that cool Pepsi container. It cools and it forms liquid droplets, right? So condensation can happen on anything when you've got water vapor coming into contact with something cool. Not like cool, but like colder, I should say. Okay. Forms liquid droplets. So that happens. We're going to make a little note here. On the side of the beaker, near the warm water, in that experiment that we did yesterday, right? It happened inside the beaker when those water droplets, that water vapor, came into contact with the smoke particles. So it contacted and the other example would be when you have a cold can of pop. You guys all say pop, not soda, right? You guys know that it's a regional thing? Did you know that? Yeah, they're like maps. You can tell where people are from by what they say. It's kind of weird. I'm gonna say pop because that's what I grew up saying. Cold can of pop on a hot summer day. And then again, and you know that in the southeast in the United States, they call them all Coke. Like you go to McDonald's, I want a Coke. What kind of Coke do you want? I want Sprite. Like that's how the conversation goes. It's interesting, right? You've lived in the South, right? Is that true? Yeah. I've not lived there, but that's what I've heard from friends that have said that. And just to be clear, that water comes from the air, right? More writing. Is that what you said? Well, I don't want to write any. We're like, really? Come on. All right. We only got halfway done with this question. Jeepers, creepers. That's okay. That was a good conversation. What's evaporation? What's evaporation? Shh. What is it? Oh, you're fine. You know. Jack, get us started, will you? What's evaporation?
I actually don't know.
Okay.
This one right here, I thought it was the other way around.
Gotcha. Okay, so you had in your head that evaporation was condensation? Was what you're thinking
I
of?
thought that evaporation was water turning into vapor.
It is.
Oh.
You're right. Liquid water. Let's write it down.
I knew it. I was just trying to get everybody to correct me.
You're just seeing the video.
Yeah, just seeing if you guys know.
Just a little test.
Mhm.
Yeah.
You just say what makes
Tagging everybody for the
I'll just make sure.
Just making sure you're paying. I do that all the time, right? Making sure you're paying attention. Yeah. Yeah. So liquid water turns into water vapor. Yeah. What's up?
It's like when the sun heats up molecules and then on their surface. Pretty much.
What's that?
Like the sun heats up molecules.
So the sun heats molecules. Molecules of what? Oh, okay. On the surface? What of it? It just heats them up. So one thing, so we're gonna step into the next thing that we're gonna do in a second. I want you to pay very, very close attention, Jack, and everybody else, but to what they define evaporation as. Because there are some very specific words and ways to word things. We're gonna come back to this. So don't put this so far away that you can't pull it out. What I'd like you to do is to send the person with the longest pinky finger from your table up to come get papers. Measure your pinky fingers. Quick, quick, quick. No, it's not. Right up there, a little gray sheet. You're not impressed, are you? All right, quick, friends. Make it happen. Wow, what? It is a lot of words. It's not like that the whole time. I don't know why it does that. We're just gonna finish that definition after we watch this. I'm just tired of talking to you. Not really. I just wanted to keep moving. All right. Ladies and gentlemen, my friends, we are going to start, I think, this video. I don't know. It starts that way, but it should just keep going. Why is this not playing?
Why is there so much words up there?
Just chill out a second, friend. Just relax. There we go. Now there aren't a lot of words. There are questions for you to follow along with. We're doing this now as opposed to as homework. So you're welcome. Hey, thank you.
Water is all around us, and its importance to nearly every natural process on Earth cannot be underestimated. It is the only compound that can be found naturally as a liquid, gas, and solid. The process by which water moves around the Earth, from the oceans to the atmosphere to the land and back to the ocean, is called the water cycle.
Ding, 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 ding,
Water
ding,
regulates
number one.
climate, storing heat during the day and releasing it at night. It carries heat from the tropics to the poles by sea and by air. Let's follow a single molecule of water beginning in the ocean through the paths it might take before eventually winding up right where it started, back in the big blue sea. The fuel for this journey will be provided by our planet's prime energy source, the sun. During the day, the sun heats up the air and ocean surface, causing water molecules to evaporate.
Look at that. It's like
Evaporation occurs when a liquid molecule of water escapes into the air as a gas. This scientific visualization shows how water evaporation, indicated in turquoise, is driven by the energy of the sun. Notice how the rate of evaporation pulses over land. It speeds up in the day and almost disappears at night. Over the ocean, evaporation appears to remain constant both day and night. Water in the air in gas form is known as water vapor. The molecule is now fresh water, having left the ocean salt and other particles behind.
The water evaporates and goes into the atmosphere, and then it doesn't necessarily just turn around and fall as rain or snow.
Condensation is the process by which water vapor molecules cool, stick together, and become liquid again in cloud formation. This often happens high in the atmosphere, where the temperature is much lower than it is near the surface.
Shall I pause
What
it?
is,
Okay.
just like we have
Maybe.
currents in the
Can I
ocean,
not stop? Oh my gosh. There?
Condensation is the process by which water vapor molecules cool, stick together, and become liquid again in cloud formation.
Okay.
Repeat that.
So water vapor cools, sticks together, or turns to water and sticks together in clouds. There's a second half to that question. I'm guessing they're talking about it in a second.
This often happens high in the atmosphere, where the temperature is much lower than it is near the surface.
what happens in the atmosphere is, just like we have currents in the ocean, we have winds in the atmosphere that actually, to some extent, drive what goes on in the ocean currents. Materials in the atmosphere can travel actually a great distance, sometimes, a quarter of a way around the world, until they get to the point where they actually turn into rain or snow and thereby fall back to the ocean or fall back to the land.
This is called precipitation.
This is number 6.
If the water molecule falls on land as snow, it may be stored for a very long period of time in a polar ice sheet or mountain glacier, depending on climate conditions.
When rain falls or the snow melts, typically the next place it goes, it infiltrates into the soil. So soil is not a solid, it's not like a rock. There are pore spaces in there, and those can be filled with water. And typically there is a certain amount of water in the soil at all times. If the soil is completely dry, then plants wouldn't be able to grow.
If soil becomes saturated, any additional rainfall will collect in puddles and streams. Soil water that percolates deep enough will help to recharge an aquifer.
An aquifer is any underground geologic formation that stores water. So it's typically either rock with a lot of cracks in it, or it's sandy layer. Sand has a lot of pore space in it and store a lot of water.
The water molecule might remain in an aquifer for more than 1 million years. More likely, it would help to replenish a stream, which would feed into lakes and rivers. Eventually, the water molecule will return to where it started, the ocean. People also have a role in the water cycle. By pumping water out of the ground for irrigation, cutting down forests for development, and building roads and other concrete surfaces that lead to runoff, people can have a serious impact on the path a water molecule takes.
The most obvious way that people affect the water cycle are the ways that we control the water after it's fallen on the land surface as rain or melts as snow. But we have put in dams and rivers to hold this water. We also pump the groundwater out and use that. So these water resources, we call them, are really us taking a natural part of the water cycle and using it to our benefit.
The water cycle also affects and is affected by climate variations.
The water cycle is one of the ways that we will really feel any changes in climate. So climate changes will feed back to water cycle changes, things like how much precipitation an area receives, the frequency of droughts and floods and this sort of thing.
The water cycle is the adventurous journey that water takes through the oceans, atmosphere, and land, driven by the sun. Improving our understanding of the water cycle and how it is changing will be critical for future decisions related to water management, agriculture, natural resources, and climate change.
Okay. Go ahead and work on number 10 real quick here. Talk to your table mates. See if you can figure it out. Get it done.
It's this one. Point it to the yeah. I said underground.
That picture's a little dark, so it's hard to draw everything, but do your best. Yeah. What's that? All right. Were there any of those questions that you got stuck on or that you need help with? Is it making sense? What's that? The second part of 5. Yeah, what did you know? Did you look? I thought that they were going to say it, but they didn't. Did you notice what was in that? No? Here, let's go back and see if we can see it.
Layer, sand
there it was.
has a lot of pore space.
No,
in
where did it
can
go?
Store a lot of water.
Blah, blah, blah. Nope,
The
stop.
water molecule might
Pause.
remain in an aquifer from
Blah, blah, blah. Did I go back too far?
indicated in turquoise, is driven by the energy of the sun. Notice how the rate of evaporation pulses over.
Come on. Is it there?
Molecules
There it is.
cool, stick together, and become liquid again in cloud.
What's in there? What do you think that is? Might be ice. What else exists in the atmosphere besides just gases? Do you know?
Sure.
What do you think it might be? This is where we're forming a cloud. Think back to what we did yesterday, you guys. What'd you say, Elena? Smoke. And smoke is really just little tiny dust particles, right? So it doesn't necessarily have to be from smoke, but any little particles of dust, right? Any little solid particles of dust. Because remember that condensation generally needs to happen on some sort of surface. It needs something to condense onto, okay? So it's generally just little tiny bits of dust or stuff that's out there. Okay? Other questions? This is what the colored, the in color version of your water cycle looks like. Help me out. Where does each of those labels need to go? Give me a start, Elena. What you got? The squiggly lines over here. Go, Beth. In between the two clouds, that's where that condensation is happening. All right. Miss Sydney, what else you got?
For precipitation, I have it on the raindrops.
On the raindrops kind of over here? Yeah. Cool. And then there's one more. What's that word? Infiltration. What does infiltration mean? What does it mean to infiltrate? Do you know? Like not necessarily in science. Have you heard that word before? Yeah. Colin, what does it mean to you? To infiltrate.
Infiltrate their bases.
What did you say, Jack?
Nothing.
No, I what you said I think is fine. I just wanted to know what it was.
It was what Colin would say.
But go ahead and say it, sweetheart. I don't want to waste time.
Nobody can.
Come on, Jack,
I
go.
said infiltrate the bases.
Infiltrate their bases. That's absolutely correct. What does it mean to infiltrate? Like, what does that mean? Invade. Yes, that's what the word infiltrate means, you guys. I don't want you to get upset. I want you to use your outside context to figure out what science means. I've told you this a bunch of times, and I'll continue to do it because it's my job. Science uses big words a lot of times, but you can use your outside context and what you've learned before, whatever the context is, to try and help figure out something if you see a word you don't know. Infiltration means to get into, right? What does it mean in this case? The water is getting into what? The ground, yeah. To infiltrate.
That on our paper. Yeah, that arrow.
I know, that's why I showed the picture to you. So you can draw it now. Or you can just put like a little, hey, it should have been there. Yes, but it goes down here. I want to point that out to you in case perhaps tomorrow on a quiz at the beginning of class you see that word. So you're not like, what does that mean? Because now you all think Jack says infiltrate their bases. You're like, yeah, I got that. I know what it is, right? You're laughing now, but you'll say thank you to him tomorrow after you take your quiz. Yeah, you can say it now even if you want. All right, put that one away. I want you to get out your Starburst conclusion questions. Oh my goodness. Rocking with Starburst conclusion questions. The ones that I was so excited to do yesterday, as you may remember. But now I know that you've got them done. Right, Colin? Sweet. Michaela, you got yours done? Excited? All right. Quick. We're going to go through this. Bless you. All right. David. Can you explain to us why the rock cycle is a cycle?
It keeps repeating itself over a long period of time.
That's exactly right. It just keeps going and going and going, right? Yeah, awesome. All right, number 2 says, compare and contrast the processes that created the three main types of rocks. What are the processes that create the 3 main types of rocks? Tell me one of them. Okay, hold on. That was a lot. Go, Olivia, what? Okay, that's one. What's another process that creates a kind of rock? Yeah. Heat and pressure. And what's the other one? So, again, I think you guys said this, but magma cooling gives you what kind of rock? Igneous rock. Heat and pressure gives you metamorphic. And then what's our last kind of rock? The rock is sedimentary, and the process is compaction and cementation. There are 2 other processes that we've talked about a lot. They don't make one of the rocks, but what do they do to the rocks? They change them. The 2 that I'm thinking of, one was weathering and erosion, right? And weathering and erosion, what does that do to rocks? Breaks them apart? And what's the other type that can like break down rock? Melting. I'm melting. So these do not create rocks. These get rid of rocks. Now, I just listed them. We did not compare or contrast. Help me out. Alexandra, can you compare and or contrast 2 of those?
With heat and pressure, magma going from hot.
Absolutely. That's fantastic. So these both have to do with temperature, right? Yeah. So these 2 over here, are both related to temperature. Heat and pressure causes that metamorphic rock has to get warm. What about for igneous? Is that getting hot? It's getting cooler. So they both have to do with temperature. They're actually doing different things. Is that a comparison or a contrast? It's a contrast, right? All right, what else you got? Compare and contrast for me. What you got? Give me something else.
Heat and pressure, compression, cementation, both have pressure in it.
Absolutely. Good call. Yeah. These two both have to do with some sort of pressure being applied. Yep. Yeah. And is that a similarity or a difference in that way? Similarity? All right. I'm gonna move on and leave that there. Oh, question.
May I go to the back?
You may. We already know that you can turn a sedimentary rock into a metamorphic rock. How could you turn a sedimentary rock into an igneous rock? How do you get anything into an igneous rock? What do you have to do first? Gotta melt it, right? Melt it and cool it. Then you're good. Boom. All right, number 4. Of the 3 types of rocks you investigated, which would most likely contain identifiable fossils? Sedimentary, and it's only sedimentary. Why? Yeah, so magma is liquid rock, right? Any sort of dead animal or any sort of dead plant or organism, if it is melted, any of that like remains there, bye-bye, right? Can't see it anymore. So that's for sure not going to happen. And in order to make a metamorphic rock, what do you have to do? Heat and pressure, right? Not going to happen. Yeah. So that all that heat and pressure would, again, eliminate any option for that. I did go get some rocks this morning from Miss McGrain, who's like our rock expert. I was going to show you. A lot of you have seen fossils before, but just in case you haven't, or it's been a while since you have, I just wanted to make sure that like I didn't, spend a whole week talking about rocks and not actually show you any. So if you want to come look at these later, you are absolutely welcome to. But I want to show you this. Oh, there's my hand really big. Hello. Let me zoom out a little bit. Okay, so this rock here has some fossils in it. So therefore, we know for sure that it's a what kind? It is, absolutely. But you can kind of see these fossil, I think this was like a coral or something that's in here. Do you see that? All those little bits. There's some more on this side over here too, maybe. Like here, and here. So anyway, sedimentary rock, it's pretty cool. If you want to come look at it after class or at the end of class, you are certainly welcome to. Here's another piece of sandstone. So sandstone is primarily made of what? Sand, right? And it's going to be sand. There's going to be pressure, right? And cementation that's going to cause that to create into rock. Now, the reason that I pulled this sandstone out also is that I've also got this piece of this stuff called quartzite. So that's what the quartzite looks like. And the cool thing about the quartzite is that the quartzite was once sandstone. So this turned into this. How do you think that happened? Metamorphic, right? So you take this stuff that has been compacted. So you have a pile of sand, essentially, right? You compact, push it. It cements together and it creates, this is not just I can't just crumble this, right? So it's actually a rock. But then if that gets buried underground, pressure, quartzite can be formed. So this is a metamorphic rock that is formed from this, okay? This one here, this is called schist. I just like that name, I think it's funny. That is also a metamorphic rock. It's really shiny and pretty. And then, do you guys know what this is? Granite. Yeah, this is the stuff that's on your counter. What kind of rock is granite? Igneous. Is it intrusive or extrusive? Intrusive igneous rock. That'd be a good word to know tomorrow. And then this right here is pumice. This is extrusive igneous rock. So that's just lava rock that came from a rock or from a volcano. Oh my gosh, the bell's gonna ring, but not quite yet, friends. I've got 3 minutes, and we've got one more question to answer. So stay with me for just a second here. Actually, I'm gonna do like this. I'm gonna unsplit it. Which specific processes in the rock cycle occur beneath the Earth's surface? What do you say? What did you guys say? Heat and pressure. So that creates your metamorphic rock. Are there any others? The cooling of lava, some of it can, right? The intrusive, right? So there's some cooling. What else? Melting? Yeah. I think those are the big three, right? Do we miss any others? I think that's it. Cool. All right. Now you can pack up your bag. You've got a minute left. We will do a bunch of lab stuff tomorrow, so make sure that you're ready to go after we take our quiz. It'll be great.
Will you sign this? Because I was gone.
Yes, absolutely. Give me just 1 second.